Hi there. These are three of my Milwaukee M18 and M12 lithium-ion battery packs. The cells in these three battery packs are out of balance. How do I know? In these two M18 12mAh battery packs, for instance, when I press the battery check indicator at the front, it indicates that the battery is not fully charged. But when I put the battery packs into my Milwaukee charger, the charger indicates that the battery pack is fully charged. How that happens is that some cells in the battery pack are undercharged, whereas other cells are fully charged. And therefore, the battery charger only detects the total voltage presented and thinks that it is fully charged. So over the past 2 years, I have been using this SKYRC M6 DAC balance charger. Unfortunately, it has stopped working. And so I decided to purchase the SKYRC D750MIX. This is a 6S balance charger, whereas this is a 8S balance charger with a much higher charging power rating. Join me in this video as I unbox this charger and show you how I open up this M18 12mAh battery and use balance cables and charge cables to connect to this charger to charge it up. As it turns out, you see later in the video, the two M18 12mAh battery packs and M12 6mAh battery pack, the D750MIX would not start charging any of these packs because the voltage difference between cells in the packs is too high. Largest voltage difference within each battery pack for the M18 12mAh pack 1 is 0.691 volts. For the M18 12mAh pack 2 is 0.626 volts. For the M12 6mAh pack is 1.37 volts. So instead, I put together a 4S pack of brand new Samsung INR 18650- 30Q battery cells and successfully balance charged them. Let's start with demonstrating how I know this battery pack is out of balance. The last time I rebalanced this pack using the SKYRC M6 DAC was the 28th of October 2025, and that was the second time I have rebalanced it. When I press the battery check, it shows 3 out of 4 LED lights, which means it is not fully charged. When I insert it into the charger shows a green LED light, indicating it thinks that the battery pack is fully charged. So obviously, something's wrong. And I know this pack is out of balance because when I open it up and measure the 5S 3P lithium-ion cells, I can detect which of the parallel cells are out of balance. This is the SKYRC M6 DAC 6S battery balance charger I have been using since January of 2025. It did a good job of balancing the battery packs whilst it was working, and you'll see links to the videos where I use it to balance the Milwaukee M18 12mAh battery pack as well as the Milwaukee M12 6mAh battery pack, and also some standalone Samsung 21700 lithium-ion battery cells. So this is the replacement I bought. SKYRC D750MIX AC-DC multifunction smart charger. When powered by AC supply, it is rated to 500 watts. Alternatively, by DC supply, it is rated to 1600 watts. The left-hand side display is for the charging features. The right-hand side display is when this device is used as a power supply, in which case the maximum DC power input is 1100 watts. The device certainly has a lot of features. I won't read out all the specifications, it'll bore you, but you'll see a photograph of the specifications at the end of my video. There is a safety warning. It says that this D750MIX is not intended for use by persons with reduced physical, sensory, or mental capabilities, or lack of experience and knowledge, unless they have been given supervision or instruction concerning the use of the charger by a person responsible for their safety. Failure to exercise caution when using this product and comply with the following safety warnings could result in a product malfunction, electrical issues, excessive heat, fire, and ultimately injury and property damage. And I think that is a very important safety warning to take note of. And lithium batteries can be dangerous if defective or mishandled. Let's unbox this. There's an instruction manual, a very simplified hard copy version. The more detailed instruction manual has to be downloaded as a soft copy. Instructions about battery connection sequence and safety precautions when connecting with a 2SKYRC battery via banana connectors. A sheet of QR code stickers, AC power supply cord, the unit itself, physical dimensions, it is 180 millimeters wide, it is 112 millimeters tall, it is 136 millimeter deep, and weighs 1.626 kilograms. On the left is the display and control buttons for the charging and discharging profile, as well as device general settings. On the right is the display and control buttons when used as a power supply. When I power up this device, I will talk about the various features and buttons. On the left is channel A, on the right is channel B. That is the 8S connector with a negative sign showing the leftmost is the negative pin. That is the temperature sensor connector. That is the XT60 charging and discharging port. Similarly for channel B. Nice big ventilation. On the left, there is a USB-C connector to enable charging of USB devices. This is external discharge port. That is an XT60 connector, and that is a communications connector. That external discharge port and communications connector allows this device to work with this SKYRC BD380 Plus battery discharger and analyzer. In a separate video, I will show how this device works with the SKYRC D750MIX. When using AC input power, the maximum input power consumption is 500 watts. At the rear, an IEC power input socket, the device accepts AC power from 100 volts up to 240 volts. Alternatively, the device can be powered by DC input power supply ranging from 9 to 49 volts, and this is an XT90 connector. It's important that the device is not connected to DC input and AC input at the same time. One of these must be disconnected for safety reasons. Two nice big ventilation fans. On the right hand side, there are two XT60 sockets to provide power supply output. When using DC power supply input, the maximum dual channel power consumption is 1600 watts, or alternatively, the maximum single channel power consumption is 1100 watts. Underneath is a label stating the electrical specifications of the device and also a serial number, which I have covered up. The best way for me to explain the many features of this charger is to open up this battery pack and connect balance and charging cables to this charger, and then make changes to the settings. I'll be wearing safety goggles whilst doing this project. Before I proceed, let me caution viewers that opening up lithium battery pack and making connections to it to the charger is a risky process and can be dangerous, can lead to explosion or fire of the battery pack if it is mishandled. So do not do this unless you are qualified and have experience with handling such battery and charging systems safely. There are 8 Torx T10 screws, 1, 2, 3, 4, 5, 6, 7, 8. These 4 screws hold the bottom casing to the top casing. These 4 screws hold the battery pack to the bottom of the battery casing. I will remove these 4 screws first. I want to add that I have a fire blanket as a safety precaution nearby. These are the 4 short screws. Put them in a container so I don't lose them. By the way, even better, I've put the fire blanket on top of the workbench, so it's much easier for me to just wrap it over and cover the battery if necessary. These are the 4 screws for the battery casing. Since I have previously opened up this battery pack, I had marked the contacts for the 1S to the 5S. The Milwaukee M18 12mAh lithium-ion battery pack is built from 5S 3P cells. So there are 5, 10, 15 of these Samsung INR 21700-40T 4000 mAh battery cells. Each cell has a nominal voltage of 3.6 volts. So 5 cells in series provide 18 volts. So 1, 2, 3 are in parallel, 1, 2, 3 are in parallel, 1, 2, 3 are parallel, 1, 2, 3 parallel, 1, 2, 3 parallel. So there's 3 layers of 5S cells. And by the way, I bought a lot of Samsung lithium-ion battery cells in order to replace this battery pack as well as other Milwaukee battery packs I have. I'm only rebalancing this battery pack in order to demonstrate the functions on this SKYRC charger. Because I have previously rebalanced this battery pack 2 times already and it's still out of balance now, my best long-term course of action is just to replace all the 15 cells. So if you like, subscribe to my channel and join me in that video when I disassemble this battery pack, replace it with the new Samsung cells, and use my Glitter 801H spot welder to weld the contacts to the battery cells. So this is the negative contact for the battery pack and this is the positive contact for the battery pack. This is the negative contact which is connected to this negative contact. This is the 1S contact. This is the 2S contact. This is the 3S contact. This is the 4S contact. This is the 5S contact. Be very careful not to short circuit anything. This is a 8S balance cable that I made. You'll see in the link above a video on how to make a balance cable. I only need the 1S to the 5S connectors. Therefore, I've taped off the ends to the 6S, 7S and 8S connectors so as not to have a short circuit. This is the negative ground cable and it needs to connect to this negative contact. This is the 1S balance cable and it needs to connect here. This is the 2S balance cable and it needs to connect here. This is the 3S balance cable and it needs to connect here. This is the 4S balance cable and it needs to connect here. Lastly, this is the 5S balance cable and it needs to connect here. I've now completed connecting the 5S balance cables to the battery pack. In the soft copy of the user manual, pages 13 and 14 are missing. So the instructions for the lithium battery program are not complete. However, when I look at page 15 for the nickel metal hydride and NiCad battery program, at the bottom of the page there are important notes. It says ensure that AC and DC power are not connected simultaneously, and it also says do not connect the battery before powering on the charger. I do not understand why, but I will follow the instructions to not connect the battery before turning on the charger. Turn on the power to the charger. Connect the balance cable to channel A. And it detects 19.31 volts for the battery pack. Press button A and it shows the voltages for the 5 cells. Press A again. Press A again. Now connect the channel A charging cable. The display says channel A lithium-ion /5S balance charge, measured voltage 19.32 volts. Charging current applied 0 because it's not yet started charging. 0 milliamp hours. This shows the amount of charge capacity that would have been sent to the battery and the power watts used. And that is time for how long the charging cycle has taken place. This is for channel B, but there is nothing connected to channel B. This is the power supply. It says DC power off. I can change the voltage as well as the current. I can do a short press or long press of this scroll wheel. A short press gets me to the charging profile. I select the battery type, click. I can choose LiPo, lithium-ion, lithium-iron phosphate, lithium high voltage, nickel metal hydride, NiCad, and lead acid. Scroll back, choose lithium-ion. Scroll down, the number of cells. This is a 5S battery pack, so choose 5S. It can go up to 8S obviously. The task, I can choose to balance charge or just charge it without balancing, or I can charge it to a storage charge, or I can choose discharge mode, or to use the charging of ports A and B in parallel, or I can choose reverse discharge, which means to discharge from, for example, channel A to channel B. I choose balance charge. Condition for the Samsung INR21700-40T battery cell, I choose a standard charge voltage of 4.20 volts, and that's according to the specifications for the battery. Cycle, it can go from 0 to 3 cycles. I will choose 0. Charge current, the lowest at 0.1 and goes up to 32 amps. I will choose standard charge of 2 amps. Temperature cutoff, I'll keep the default of 50 degrees Celsius. It can go up to 65 degrees. I'll just keep it at 50 degrees. I can click to start or go back. A long press now on the scroll wheel. Gets me to the general settings. Task parameters, I can choose the safety timer to protect the device. It goes up to 720 minutes. I choose to have safety timer off. Maximum capacity 12 amp hours, and that is the maximum capacity of this battery pack. Trickle charge, I'll put trickle charge on. Keep voltage is presently off. This feature enables or disables holding a voltage. If the difference is greater than 0.02 volts between each cell detected, then a small current will be applied to keep the battery voltage. Let's say I turn this on. Float, I'll keep float off. In the user manual, there's no explanation of what float is in the case of this charger. I don't know the difference between trickle charge and float. Go back, preferences, language, English. I can choose Chinese, Japanese, Deutsch, French, Espanol. Keep English. Maximum input power. That's not selectable. It just tells me it's 500 watts for AC power. Minimum input voltage goes from 9 to 34.5 volts. I assume this is for DC power supply input. I will make that 12 volts. LCD backlight is on middle. I'll make that high. Key press beep can be off, low, medium, high. I'll keep it on low. Notify beep can be off, low, medium, high. I'll keep it low. Completion tone, I'll keep it on once. Warning, I'll put the warning off. Go back. Battery meter. This is interesting because battery meter measures the voltage and internal resistance of each of the cells. So cell pack 1S has a voltage of 4.061 volts. Internal resistance is 8.3 milliohms. The numbers in red indicate the highest voltage and highest internal resistance detected. Cell pack 2 is 3.831 volts. Internal resistance 7.3 milliohms. Cell pack 3 has a voltage of 4.073 volts. It's highlighted in red, and the internal resistance is 8.3 milliohms. And the internal resistance measure is useful because I can measure the internal resistance of my new lithium-ion cells and then select them so that they are put into a pack where they have very similar internal resistance. Go back. Factory reset, click on that. No, I don't want factory reset. User guide gives you a QR code to scan. System information, hardware version 0.1, firmware version 2.87, Bluetooth 9B59, passcode 5793. Regulatory, and back. I previously made the charge current 2 amps. However, that is 2 amps per cell. Since there are 3 cells in parallel, the total charge current should be 2 plus 2 plus 2, which is 6 amps. So I'll scroll down and make this 6 amps. I would rather a slower charge rate for safety as well as better longevity of the batteries. I can start. Press start. Oh, it says cell volt difference. I think it may be that the contacts to one of the balance cables is not good. I'll have to check. Go to battery meter. I will check contacts for 1S and 3S. I have reconnected the balance cable contacts. I'll attempt to restart charging. It still tells me cell voltage difference. It doesn't like the cell voltage difference. And from the battery meter, the cell voltage difference is not much, but somehow it doesn't like it. That's too much difference. I'm very surprised with that. What I will attempt to do now is, instead of charging it, I will discharge it and see if discharging it helps bring down the voltage to a level where it is happy to balance charge again. So I'm now selected task is discharge. I'll make the target discharge voltage 3.20 volts. I'll make the discharge current for the 3P in parallel 3 amps. The maximum is 4 amps with the internal resistance load. It can be much higher using the external discharge port. Let's see if this will work. Cell voltage difference, it still doesn't like it. So even discharge, it doesn't like it. For this battery pack, the maximum voltage difference between the cells is 0.691 volts, and according to this charger, it exceeds this charger's threshold, and therefore the device will not charge and it will also not discharge. That shows how bad some of the cells are in this battery pack, and that's why I bought those new Samsung lithium-ion cells to remove and repack this whole battery pack. I have here another Milwaukee M18 12mAh battery pack. This one has been rebalanced 3 times. What I'll do is disconnect this battery pack and connect the charger to this second battery pack and see how it behaves. This is the second M18 12mAh battery pack that I've connected to the charger, and using the battery meter, it detects that cell 3 is 4.053 volts and the lowest cell voltage is cell 2 at 3.427 volts. That gives a maximum cell voltage difference of 0.626 volts. If I go back using the same charging profile, if I go to start, you will see that it will not proceed because again, this cell pack is bad. The maximum cell voltage exceeds its threshold. Here we are, cell voltage difference warning, and it will not proceed. So in a sense, it's good that I've been able to include situations where the balance charger will not operate because the cells in a battery pack themselves are in too poor a condition to be rebalanced. This is the last battery pack I have that was rebalanced. It's a M12 6mAh. It has been rebalanced 2 times already. The last time it was rebalanced is 19th October 2025. Let's check the condition of this battery pack. Let's open up this battery pack. At the bottom, there are 4 Torx T10 screws to remove. Push these spring tabs in, and I will be able to slide this red cylinder out. The M12 6mAh battery pack uses Samsung INR 18650-30Q lithium-ion cells. There are 6 of these cells, 3 here and 3 here. The battery pack is configured in a 3S 2P configuration. So these 2 are 1S, this is 2S, and this is 2S, and these 2 are 3S. Before I connect the balance cables to the contacts on the battery pack, I'll use the multimeter and measure voltages between the 3 cells. From the diagram, this is the C1 minus contact, which is the ground. This is the thermistor contact. This is the C1 plus contact to cell 1. This is the C2 plus contact to cell 2. And this is the C3 plus contact to cell 3. So I'll measure voltages from ground to 1, 2, 3 points. First measurement between C1 minus and C1 plus is 4.12 volts. Second measurement from C1 minus to C2 plus is 8.27 volts. Third measurement from C1 minus to C3 plus is 11.05 volts. Therefore, cell 1 pack equals to 4.12 volts. Cell 2 pack is equals to this minus this, which is 4.15 volts. Lastly, C3 is this minus this, which is 2.78 volts. The maximum cell difference is this minus this, which is 1.37 volts. That is a huge difference. There is no way that this charger will accept that high voltage difference. So I'm not even going to try connecting it up. As you can see, all my Milwaukee cell packs are in bad condition and I have to repack these, and I did buy replacement new cells for these as well. So finally, for the purposes of demonstrating this charger, given that my 3 Milwaukee battery packs are all in unusable condition, I will use my new Samsung lithium-ion cells. I have here a 4 cell holder for 18650 cells, and I'll use this. This is the Samsung INR S30Q cell that is used in the Milwaukee M12 6mAh battery pack. For this cell holder, that's the negative. That's 1S, 2S, 3S, and 4S. Connect the negative balance cable to the negative of the pack. Connect the 1S balance cable to the 1S contact. Connect the 2S balance cable to the 2S contact. Connect the 3S balance cable to the 3S contact. Connect the 4S balance cable to the 4S contact. I've now connected the 4S balance cables and charging cable to the battery pack. In the soft copy user manual, pages 13 and 14 are missing, and I think those pages cover the remainder of the lithium battery charging program instructions. However, page 15 is the nickel metal hydride and nickel cadmium battery program. At the bottom of the page, there is an important note. It says, ensure that AC and DC power are not connected simultaneously. Second note says, do not connect the battery before powering on the charger. I do not understand why, but I will follow the instructions. So before I connect the battery pack to the charger, I'll turn on the charger. Charger is now turned on. Now I connect balance cable to channel A. The device detects a total of 13.86 volt. I'll click to set charging profile. Battery type lithium-ion, yes. Cell count 4S, correct. Task is to balance charge, correct. Target charge voltage is 4.20 volts, correct. Cycle, I do not want it to cycle, so 0. Charge current, this is a 4S 1P configuration. The standard charge for each cell is 1.50 amps. So I'll set it to 1.50 amps. Temperature cutoff 50 degrees Celsius. I'll go back and I want to see the voltage and internal resistance. So long press scroll wheel. Go to battery meter. It says 3.462 volts for cell 1, 3.461 for cell 2, 3.465 for cell 3, 3.459 for cell 4. So the highest voltage difference is 0.006 volts, which is acceptable. I'm sure that if I proceed to charge, there will be no problem. Go back. Task parameters, I'll say keep voltage on, trickle charge on, go back, scroll down, press start. There you go, there's no problem because there is no significant cell voltage difference. So that indicates the time duration charging is taken place. That indicates the charge current capacity supplied so far. That indicates the charge power. The charge rate is 1.5 amps. The charge voltage 14.44 volts. If I scroll down, that's USB power supply and I've connected nothing. If I press channel A again, it shows the individual voltages of each of the 4 cells. Press channel A again. It now shows the internal resistance of each of the 4 cells. I like the display because it provides a lot of useful information. I'll stop the charging process. Press stop. It is stopped now, and instead I'll go to discharge. I won't discharge it for long. I just want to demonstrate the process. I'll set discharge rate at 0.5 amp and then initiate discharge. Press start. There you go. It's starting discharge. It shows the red cell. I'll press A. Says discharge. Press A again. Shows the internal resistance. I'll press stop. Discharge is now stopped. Scroll back. I want to keep it at balanced charge. at 2 amps. Go back. I like this. I chose this particular model because it has a much bigger casing, and for me that means much better heat dissipation, much better ventilation. And secondly, in terms of if I ever have to, after warranty, do any electronic component repair replacement, I think it will be much easier to work with because the casing is much bigger than say the smaller models. By the way, regarding discharge feature, the maximum discharge current is 4 amps and the maximum discharge power for the main port is 45 watts and through the balance cables is 20 watts. It is not clear to me whether it's for the entire device or is it per channel. I will now demonstrate the use of the DC power supply function. The DC output voltage can be adjusted from 5 volts up to 36 volts. The output current can be adjusted from 0.3 amps up to 32 amps. I assume that's the total across both ports. I could be wrong. There are 2 XT60 output ports. Here I have a old Thermaltake TT-8025A DC brushless computer fan. It takes DC 12 volts and uses 0.1 amps. I connected it to one of the XT60 DC power supply ports. To change the voltage and current output, short press the menu button. I'm on voltage selection. I press the up or down arrow key to change the voltage. I'll keep it at 12.0 volts because that's what this device is. Up or down. I'll put it at 0.3 amps because this only uses 0.1 amp. That's now fixed. So I've connected the fan to the XT60 contacts. Long press the menu button. I can opt to have over voltage protection on or off. It is on. If I press this, it will be off. Go down. Over current protection is on. Go down. Go back. Long press the play button. It gives a warning. Connect load before turning DC on. Caution, avoid highly capacitive loads, example charges. I'll press play to continue. It shows it's working. 11.98 volts at 0.07 amps. The fan is turning. That's good. With the power supply working to power up the fan, I want to test if the charging function can operate concurrently. Short press to get to the charge profile. Everything looks alright. Balance charge. Target voltage 4.20 volts. Charge current 2 amps. I'll press start. It is charging. I'll press A. That's charging. And it shows each of the 4 cell voltages. Press A again, it shows the internal resistance for each of the 4 cells. Press A again, goes back to the main screen. So that's good. This can function concurrently to charge at the same time, act as a DC power supply. That's very good. So far, I'm happy with the features I see in this D750MIX charger discharger. Subscribe to my channel and you will see when I integrate this device with the SKYRC BD380 Plus discharger. I hope you found this video interesting. Do hit the like button and subscribe to my channel for more and help the channel grow. Thank you so much.